Hi friends, in this session we will learn about PLC. Many of you may be aware of what is PLC and many may not be. PLC stands for Programmable Logic Controller. It is basically a digital computer which is using for automation of typically industrial electromechanical process such as control of machinery on factory assembly lines or light fixture, etc. 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 I can give you a small example in short about the PLC and how it works. Let us take a soft drink manufacturing industry, a factory, Coca-Cola for example. There you can see the bottles moving through conveyors and they stop automatically at one point for filling. They stop automatically for filling at one point. Once the filling is over, they automatically move forward and gets stopped at some other point, and there they get sealed. And first point they were filled and second point they will get sealed, and finally they go and fall in their racks one by one for packing. Basically what happens in this case is once the bottle gets filled, it gives a certain input through some devices, so through some sensors to the PLC saying that yes, the bottle is now filled. So what the PLC do is once it receives a command input, it generates an output, and through that output it controls some particular equipment, maybe in this case the equipment which is filling this bottle. So the input is saying yeah, it's filled, the output will stop the filling machine. So this is the way it works. That is what PLC. And the major players in this field are basically Allen Bradley, ABB, Siemens, Schneider, etc. 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 They are the major players in this field. They generate hundreds and thousands of drawings for PLC input output modules. What they do is they customize these commands for their bulk production of drawings. You may not be required this function quite often, but at sometimes you may require to insert 2-3 blocks or 10 or 15 blocks somewhere here and there in your project. So in that case this is very useful. There are two ways. One is parametric and the next full units. Let us go one by one. This is my sheet, okay, title block. This is a standard title block. I don't want to change this title block size. And this is my AutoCAD training project which is active now. You can see it is highlighted, and the active sheet is E001. Again that is also highlighted. So this is my project and this is my sheet number. In sheet number 1 I am going to put few modules. Here you can see variety of module manufacturers name: ABB, Allen Bradley, Aromat, Automation Direct, Eaton, etc. etc. Siemens, Schneider, Mitsubishi, Honeywell. They are major players. They are all here. And once you go and press this plus button, you can see all this falls under Allen Bradley or the makes of Allen Bradley. These numbers are basically nothing but the series, 1715 series, 1734 series, like this. Okay, even under this serial number series you can see variety of modules: analog combination, analog input, analog output, discrete combination. Again these are the types of modules which comes under the 1794 series. If you go to discrete output, here you can see all these are discrete output modules. If you go and pick discrete input, here you can see these are all major input modules. Okay, so now for example let us choose this one, 1794 IB16 DC supply is there. it is 16 point. It is having basically 16 input points. 24 DC supply is required for this. The description is 16 point syncing input. TB3 is nothing, the basic terminal base of this particular module, that is called TB3. Okay, and these are the graphic styles. There are variety of graphic styles available, readily available. You can choose one among this. And horizontal and vertical, this is again another option. If you click horizontal, you can create the modules in this way. See the preview. And if it is vertical, this style. Again, it depends upon the standard which you follow. Normally, in IEC standard, people use horizontal module. Okay, whereas in NIMA standard, the modules will be vertical. This is a basic difference between NIMA and IEC. In IEC, the wires come from top to bottom, but in NIMA it is from left to right. And scale factor, this is one is absolutely okay for me at this stage. Sometimes your title block may be in inches, so you may require to convert the module size as per your title block. So this 25.4, this is nothing but in inches. 1 inch is equal to 25.4 mm. This is again 0.039. This is 1 divided by 25.4. So these are the scaling factors. As per your title block, you can use any one of this scale. For me, in this case, 1 is fair enough. So I am going to put my module here. This is my module. Okay, I am going to keep it here. Spacing, it is asking for spacing. Spacing is the distance between two IO points. Remember, this is a 16 point module. That means there are 16 input points. Apart from these input points, there are other points as well, like 24 volt DC plus and 24 volt DC minus. There are many common terminals. So 16 is the input terminals. So spacing it is asking for. Let us say 1 in this case. Insert all. Here is one option, allow spaces or breakers. We will come to this later on. So I am giving the space factor 1. Okay. Insert all. Okay. Module number. Let us assume this is my first module. This is my first module. So I am putting 1. First module 1. Coming back, this is the way different types of IO description writing. I mean, people follow different methods. If I choose this one, first one means, that means I stands for input, 01 stands for my first module. You remember I selected this as my first module and 00 is the channel. And in this way, there must be 15 channels, 0 to 15, that is 16 total. It starts from 0 and ends at 15. That means 16 inputs. Okay. Now, do you want to break it now? It is asking whether you want to break this module into 2 or not. I am saying no. Continue, no break. See, I don't want to disturb the size of my title block. But if I provide the space factor 1, what happens is this overflows, this particular module overflows into my title block. Let us zoom and see what is it. This is AB is the make, 7094 IBCs in the series, module 1, this again flux IO modules, 24, these are all description about the modules. These are the terminals, 24 volt DC plus. We have to give a 24 volt plus supply to here and common here, and the input starts from here. See, IN0, I0100, and like this it will go 15. This is something wrong in this module. Okay, this is the way it functions. Now coming back, if I provide so one with a 1 mm space, I cannot with 1 mm spacing, I cannot fit my module within this title block. So what I have to do is, I will show you once more. Insert PLC, same module I am using again. I am putting it here now, but I am giving this space factor 0.75. Okay, module number I am putting is 2. Remember, this is just an example. Okay, see, automatically it starts reading from second module. Okay, no, continue, no break. Now it's fit. But what happens is, sometimes the distance between these 2 points may not be sufficient for you, because what happens is, at times you may require to show some devices, some wiring of certain devices here. In this point you may require to show, okay, this input here, I will suppose I need to show a device, a big device like this. I'm trimming this wire. Let us assume this is a device. Okay, in fact this is not a block, I have made this here just for your understanding. So we may require to give some supplies to 220 or 24 volt supply to this device, external supply to this device, and we may require to show a few terminals inside this instrument. And in that case, what happens is, we cannot properly draw a second wire here, second input wire here, due to insufficient space. So this is the freedom which this PLC function gives you to space the distance between modules, in connections between distance between points as per your requirement. So 0.75 is not sufficient for me. 1 is, see how my modules goes. So I want to break my module now. So in that case, what I can do is, I will insert, again I am using the same module, okay, putting it here now. I want 1 as spacing, okay, 1, okay. Let us assume this is my third module, okay. I am choosing this style. Break now. Now it is braked. The second module I am placing here. Now you see, I have sufficient space, but these things, no, this get little bit disturbed. You have to adjust with a moving attribute. Select, go here. From here you have to select move attributes. Okay, again, if you don't remember this particular point, icon menu, AutoCAD electrical AE, move attribute,
In this session, we will learn about inserting PLC modules through a different way. See, I am just going to in icon menu. There you can see the PLC IO option here. Here again PLC IO modules. So here you can see the different makes like ABB and Allen Bradley are the two manufacturers which is available in my library at present. once you click this plus, you can see many others falling under this Allen Bradley brand name. These are all different series of IO cards. There are different series. So, for example, if I want to use 1794, which many industries commonly use this series 1794 Flux IO. If I click here, under this there are many options like analog combination, analog input, analog output, and many. So even under this, for example, if I go to discrete inputs, again there you can see many others. They actually they are different in the number of channels and even the input supply voltage in this particular modules. Few are of this, for example, IB16, which is operable in 24 volt DC supply, and IA16, which is 110 volt AC supply, like that. And 16 is basically 16 channel. You can connect 16 inputs to this particular module, and for IA8 there are only 8 channels, and many options are there. Now, for example, let me put 1794 IB16 here. Again here, this graphic styles, many styles. You can use whatever you want. I prefer to go with style 1, and once I click IB16, it comes here. You see here the description. You can see it have 16 point sinking input. TB3 is the terminal base of this particular module, and the rating is of 24 volt DC. Okay, I'm going to insert this module right here in my drawing. The spacing between IO points. We know IB16 has 16 inputs. So what should be the spacing between each IO point or each terminal blocks? So let me put 0.75 for example. Okay, again, if you want to add spaces or breaks, now for this particular instance I don't want any breaker. I'm just going to insert it. Okay, now the module number, let us say this is my first module. Okay, or A1, let us say A1, this is my module 9, and here you can select the IO description format, the IO address format. I stands for input, A1 is my module number, and the IO address, whether it should start from 00 in this format, there are many formats. Okay, so I will choose this one now. Okay, so it will ask you whether you want to break it after inserting few terminals. If you want to break it, you can choose yes, break now, otherwise no. But for this case I am not choosing no, I don't want to break it. Okay, so now my module is inserted into the drawing. AB is the make, Allen Bradley 1794 series, module A1. You remember we have provided module name A1, Flux IO, 24 volt DC. These are the descriptions which is already inside your database, and these are the terminals. Okay, this is how we can insert a PLC IO through icon menu. Now if you closely watch this, suppose you want to connect wires to these terminals, all these input terminals starting from IN0. IN means input, 0 to, you will see till 15 here, 15 input, 15, 0 to 15, that is there are total 16 inputs we can connect to this particular module. If you want to connect wires to this particular terminals or 16 TB terminal points, what you can do is, one way is you can add wires one by one like this. You can add wires, but this is time consuming, right? So another option which you should use is go to multiple bus, select component here. Okay, now you can see a green cross comes across in all these terminals. If I zoom in, it will disappear. It will disappear now. Now again, if I show you component, you see the green cross comes in all terminals. You note that this cross is on the left side of all these terminals, which is in the left side of the module. The cross is on the left side of this terminal, but you see B16, it is there on the right side. That is basically the connection point of those particular TVs. Now if I want to connect the wires into this TVs, what I have to do is, I will show you again. Go to multiple bus, select the first option, which is component. Okay, just make a cross like this for the 16 points, enter, and move your mouse towards left direction. Here it is drawn, all the 16 inputs. You can save a lot of time, and you see the connection point here. It is connected in the left side, which was there. Here you see this green cross. That is basically the connection point. That is basically the connection point. Even if I draw a wire like this, from here if I draw a wire, it will get trim here, okay, in this way. And if I want to add a 24 volt supply, 24 volt DC plus, here I can connect it like this, and here this is the negative point. I will connect it like this. But in fact, I should trim this particular wire, and I will draw a similar wire like other 15 inputs. So this is how I can draw wires to a PLC IO module. There are two ways. Basically, the standard way of drawing wires in an input module is the wire should start from left to right. I mean, the module should be placed in the right side, and the flow of wire should be from left to the module. And if I try to draw, I am just deleting all these wires. If I try to draw in the opposite direction, what will happen? Let us see. I am making it a window like this, enter. I am moving it in the opposite direction for this input modules. See, I am unable to draw any wires. I can't draw any wires towards the right direction for an input module. So for an input module, you should always draw wires to the left hand side. In this way you can draw. But for an output, let us see how it works. Again, go to PLC IO here. Now this time I am going to select, this is discrete input. I am going to select an output module, OB16. Okay, OB16. Okay, I am going to place it here. Spacing, same spacing I am going to provide for this two. Okay, okay. Module, let us say B, this one. This is my output, so I will choose O as the prefix. Okay, no, I don't want to break it. Continue, no break. It's done. It's output module. Allen Bradley 1794 OB16, module B, Flux IO 24 volt DC. The descriptions comes here. Okay, now you see the difference. In the input module is, you can see the 16 TBs on the left hand side of this module. For an output, you can see it on the right hand side. So that means you can draw wires in this. Again you see the green cross comes across all the TBs. Enter, bring it to its right. This way you can draw the wires. In fact, this one is not an output. Output is starting from out 0 to out 15. Those are the 16 outputs. Here in the top you may have to give a 24 volt DC plus supply here and minus here. From an external source you have to give a supply here. This is how it works. And for an output module, if you try to draw wire from right to left, from left to right, what will happen? I'm selecting this, now I'm trying to draw the wires towards left. Again the same thing, I cannot draw. So for an output module you should always, you can see, note this from this green mark. From this green mark you can note. I will zoom it a little bit more. See this green mark, that is the connection point. So you should draw wire from that end only, not from the opposite side. Fine. So draw wires, enter, this way. This way you can draw wires. This is how you can insert different types of module, and you can add wires within seconds. No need to draw individual wires. And if you want to increase the spacing, you can of course do the spacing also. For example, if I am going to PLC IO module 7 OB16, I am going to insert it now. See here, I am inserting the same thing here with the spacing 1. You remember earlier we provided 0.75 as spacing. 1, 1, okay. Modulator say it is C, okay. Output C, okay. No break. Now you see the size. Modules are same. Both the modules are same only, but the distance between these 2 points, these 2 pins, first one this and second one this. This is now 1 mm, and in this case it is 0.75 mm. If you measure the distance, you will see from here to here it is, see, 0.75 here in this command line, 0.75, but here if you measure it, it will be 1. So this is how you can space the distance between IO points. And sometimes what happens is, in one sheet you may need to break these modules, because like this, for example, in this input modules I may require to show some field connections. Basically these wires can be come within the panel or can be coming externally coming from the field. So sometimes some customers may ask you to few details in the field. Before going to field, I will show you one more thing. If I want to insert a push button, how I will do? I want to insert a push button in this 7PB3 it is asking. In fact, there were few I have inserted previously, those blocks are lying somewhere in this drawing. That is why it is starting from 7PB3. I have given it is 7PB1. Okay, I am not going to give any descriptions here. One option is, okay, repeat, use 7PB1. Just a minute, I will just purge this drawing. Some blocks are lying. Now you can see push button, no. We have learned few things about PLC function, these PLC modules. But you see, there are two types, parametric and full units, that is non-parametric. we will try to learn about the difference between these two. Okay, now I have a drawing called WE001. That is my current drawing. So what I will do is I will save us this into W002. It is already there, but I will rewrite this W002. Yes. Now you see the top here, the file name is WE002, but that is not coming here under the schematic subfolder. What I have to do now is right click on this, add active drawing. Say, do you want apply the project default values? Yes. Now it has become part of this drawing. The first thing what you have to do is you have to go to the properties, drawing properties, and you should change the sheet number. That is always a good practice to do. Now my sheet number 2 is ready. So first let us again rewind this thing, that is this parametric PLC. Suppose if I want to insert a 1794 series IE8, okay. Now let us give a spacing of 1, insert all. We have done already this exercise, but 1, this is my parametric PLC. Now what I will do is I will put a non-parametric PLC just side of this. Okay, let us take a PLC fixed unit PLC. Let us take 1761 AWA. See the difference. This is AB make 1761 L16 AWS the module number. Address, of course you can change a description if you want. You can put like start for disk IO9, stop for 8, jog for 7, 6. If I want to copy this thing again, see description 1 is jog, copy this description to IO point. If I say OK, it will copy it to even to 6. If you see 7, it is jog, and now for 6 also the same description. You can copy in this way also. Okay, now I am putting it. The start, stop, jog, everything is here. This is another type. One is parametric, the another is non-parametric type. And apart from this, there is one more thing, that is standalone PLC type. These different types are available here, and you can use as per your requirement. And this one looks more beautiful. This is a little bit tidy compared to the other. Here you see the descriptions, the distance between texts are not good, looking good, but here it is looking very nice. This is a block, Attaccord electrical block. Okay, now standalone PLC. In order to reach there, you go here, icon menu. Here if you click PLC IO, these are the standalone PLCs blocks. I will show you what this stands for. This is input first point 1 wire. Now I am going to insert it somewhere here. Okay, I can give the IO address I01, description again, motor start, tag PLC 001. I'm going, and even in fact you can go and see the catalogs. You can set the catalogs, lineup 1, location 01, OS or TT, whatever. Okay, now you see, and in this you will find out something very strange. That is, let us try to draw a wire from this. So in order to, before drawing the wire, we have to just to go and check whether our layer is in wire layer or not. Always make sure the layer is in wire. The color you choose red or something, some bright color, so that you can identify which is wire and which is other components. Now coming back to schematic, I am drawing a wire. So while drawing these wires in this case, what you have to do is you have to keep the snap off, and if you want to keep the grid F7, if you press F7 you can off even the grid. Fine. And now I am typing near to 3. From one end I have drawn a wire. Now the same thing, if I am trying to do it from the other end, what will happen? No, it won't catch from there. It will catch, you can draw wire from only one side. You cannot draw from here. See, I am picking this point. Okay, but what happens? It catches from the other end. This is how it works. And the same way, output modules, icon menu, PLC IO, out. I am keeping a standalone output module here. Same way you can put the IO address 001, whatever. Description again you can stop PLC 002. Okay, installation, everything you can put. Now see, this is my PLC 002. In this case, if I go to edit component and see, I have provided installation code and location code, but here I have not done that. If you want again to put the installation and location code, you can edit this, do this by editing the component 01 TT. Lineup 1 PLC 001, I for input 01. This is again PLC 002, O for output 0.01. Same, if you try to draw a wire from this end now, you cannot. You can draw wire from this end only. Again I am trying to draw from this end. See, you cannot. This is what? Standalone PLC. So you can use any of this as per your company standards and your requirement. Now if you want to edit this PLC component, a module, or if you want to custom a module, maybe you may be required to use a new kind of module which is not in your database. How can you custom a module? You can create a new module. How can you do that? This is 1761 L16 AWA. Fine. So what you have to do is you have to go to this right hand side, other tools, and here PLC database file editor. Straight away go here. Okay. So this is my database editor now. So what I have inserted now at present, this module is L16 AWA 1761 L16 AWA. Okay, let's say new module. Here I want to create the same series, a new module. Let me name this custom. That is my new module. Okay, description, if you want to put any description, 1761 custom. Module type, anything you can put. Combo, rating, I'm giving it 24 volt DC. Terminals 8 is okay. Forgot about this AutoCAD block to insert and file. If you are an expert to write list programs and all, you can do this as well. Okay, so module box dimension, you can select the dimensions like from top how much inches. This is in inches, English dimensions. If you want, you can set it in metrics as well. You can, I mean, design the box. Fine, now I'm not doing anything. See what is happening. Okay, now you see under this L16 there is a new module called custom I have created. Okay, now if I do done and insert, what will happen? Custom, I will choose this graphic. Let me keep the distance 1. Okay, see, it's a blank box, nothing. Because if you go and edit the component, here you will see edit component. I have not provided any description or nothing. It is a simple blank box. So how can I fill this box with a few attributes? Let us see. Again, go back to PLC database editor. I am selecting this custom module specification. If you go and see all these things we have put. Okay, now here terminal type, we have not provided any terminal earlier. Now we are going to provide some terminals. For input, I am going to use module information input IO point wire left. For output, I am going to select right. Again for input, I am going to select left. You should be very careful while selecting these points. Okay, this is a one-time job, so when you create a new module, you should select it very carefully as per your requirement. Left, output right, input left, output wire right. And these are another things where what you want to show, the terminals should be shown or not. Of course you should do some R&D on this. Optional, whether you want to do a breaker. If you want to break the module, if you click here, it will break the module after this point, and so on, so on, so on. These descriptions are basically what you are seeing in against the each IO point. That is what the description stands for. Okay, done and insert. Do you want to save the module? Yes. Now you can see that custom module is here again with the 24 volt DC. Now the description is 1761 custom module. All the details are here now. Now I am putting it here. Keep the spacing 1. Okay. 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 Now you see the difference. Now this is the same block. I have edited and converted this box into a module 1761 custom module. Earlier it was 1761 L16 AWA. Now I have created a new module, but of course you can change the width of this box and even the terminal type, everything you can change. You have to spend some time. The distance between these terminals, if you want to break between the IO points, all the options are there. All the options are there. What you have to do is you have to just to do some R&D sort of things, and you can create your own modules. Now we will learn about component tagging, PLC IO component tagging and PLC IO wire numbering. So for that I will insert a parametric type IO, that is 1794 IB16. I am going to select it. Oh, fine. 1794 spacing, let us keep 1. Okay. Okay. 001 is module number. I001. Break, yes, I want to break it now. I am keeping the rest here. Again, this is 1. So I have inserted one module, full module. So normally if we insert a push button or something, what happens, it will ask you for component tag. Okay, earlier we used to give with a prefix sheet number or just a PB1 or some sort of thing. So either way, otherwise you can edit the component sheet number. If this is 2 PB1, and you can do in this way. This is what we have done so far, but what we are going to do now is something different. We are going to tag this component as per this IO point. The first one, you see, input 001, that is 0001, 001, that is our module number, and /00, that is our input 0, input 1, input 2, 3, likewise. So we are going to tag the component based on the IO point. I am going to draw a wire now. Keep the snap on. Here I will draw one more like this. Now go to icon menu. Let us put a push button. No. Pick this use PLC address tab. Use PLC address. Okay. See, this is the same address which is here at this IO point. See again, push button NC next. Use PLC address. If you keep it fixed, see what happened now. Again you have to, if you don't pick this thing, if you don't pick, I am putting one more in series, this PLC, use PLC address, what happens is it will appear like this only. So this is one of the beautiful option available with AutoCAD Electrical. You can tag the components as per the IO point. And again, if you want to do the wire numbering, what you can do is properties, go to wire number, see here, search for PLC IO address, pick this wire numbering, pick individual wires. Again, this is based on IO point. Once more, you should not give this property to the project, because if you give this to the project, the whole drawing inside this will be wired in this way only. If you see the project, the property is different. But what I want to do is, I wanted to apply this property only to this sheet. So click on this sheet, right click, properties, drawing properties, go to wire numbers, and here you do select this, search for PLC address and insert, and again then you do the wire numbering. So this is all about PLC IO modules. Next we will go to panel layout. That's not in this session but in the next session. Thank you.